Good morning, students. So we'll move on to the last topic of module number 1, that is design consideration of assembler. Okay. So the last topic is multi-pass assembler. Okay. So here the name only indicates that instead of going for only one pass or only going for a two pass, okay, we'll be performing many number of passes. Okay, this scanning the program will be done multiple number of times. Okay, so because of that, we can avoid the forward reference problem example. Okay, so now you may ask like, okay, like one pass assembler used to scan the entire program. So whenever we are having this type of undefined symbols or forward reference of symbols, okay, in previous lecture and all we discussed, okay, how we but in today's session, we are discussing a problem of a forward reference, which is having a sequence of references. Sequence of references, okay, which cannot be resolved using two-pass assembler also. Okay, if you are going through pass one, okay, only one information may be available during the second pass. Second information may be available, but sequence of forward reference, if it is available, then only two values we can identify using the two-pass assembler. But later, third value, fourth value, fifth value, sixth type of values, if it is available, okay, like forward reference value is available for the operand values, okay, then it will be identified. So to resolve that, okay, we'll be discussing few examples, okay, and we are discussing about the topic called as multi-pass assembler. Okay, so here we are not restricting our assembler to perform only one pass or two pass. Okay, we are allowing the assembler to go for multiple number of passes until we find all the symbols, okay, with forward reference with suitable values. So here, for a two-pass assembler, forward referencing symbol definition are not allowed. Okay, means forward reference, if it is only one time, then okay, fine, it will be handled properly. But if the forward reference is sequence, okay, see this example. So here, we are having totally three operands, alpha, beta, and delta exactly. Alpha is equal to what? Beta. Okay. Beta is equal to what? Delta. Delta is equal to what? Reserve word 1 exactly. Okay. So beta is equal to delta. Alpha is equal to beta exactly. Just observe. T is dependent on beta. Beta is dependent on delta. Delta is dependent on 1 exactly. Okay, so now if I know the value of delta, then only I can get the value for the beta. If I know the value of delta, then only I can get the value of beta, and same, if I know the value of beta, then only I can get the value of alpha exactly. So same program, if I start assembling using a one pass algorithm, okay, see here, three different things are unknown exactly, right? See, when I execute this, alpha is equal to beta, but what is beta, I don't know. So two unknown things we have. What is that? Alpha and beta. In second line, we are having statement for beta. What is beta? Which is equal to delta. What is delta? I don't know. The delta is unknown. So now three things are unknown. But when you come for the third line, delta is equal to what? Delta reserve one exactly. So its address, whatever it is, it will be equal to delta exactly. Now during password, I found what is the value of delta. Okay, but I don't know what is beta, what is alpha exactly. So now both alpha and beta remain unknown. Okay, but delta we got to know in pass one exactly. Now during pass two, just observe, alpha is also unknown, beta is also unknown. Okay, but delta we know exactly. Okay, so during pass two, we got to know like beta is equal to delta. So the original value of delta will be made equal to beta exactly. Okay, so now delta is known, beta is known, but alpha is unknown. Alpha is unknown. Means during second pass, I can get the value of beta. During first pass, I can get the value of delta exactly. But what about alpha? Alpha remain unknown. Okay, so this will generate an error. Okay, when we end up with the program after the two pass assembly. Okay, so to avoid this, what we can do over there is, okay, some restriction we can impose for the user, like simple definition must be completed in past. Okay, means whatever the definition we are providing, okay, so the simple value should be identified in password itself. Okay, so we are restricting that it should not enter for pass two. Okay, if it enter, then it should be stopped there itself. Then prohibiting forward reference in symbol definition is not a serious inconvenience. Okay, so if you are restricting the forward reference for the programmer, then also it will not create any big issue. Okay, it can be. Okay, but also one more variety is what forward reference tend to create difficulty for a person reading it. Okay. So these are the few measures we can take how we can avoid these kind of issues, but this is not suitable for each and every cases. For particular cases, it will be working properly. Okay. So we're going for the next topic. That is, I hope you got the problem. What exactly we are facing if you are only dependent on past one and past two. Okay. So this type of example we call it a sequence of references. Sequence of forward references. He is dependent on the next one. He is dependent on the next one. It continues exactly. Okay. So next we are having something called as implementation issue for modified two-pass assembler. So here we don't have much discussion over here. See, whenever we find the forward references, we are updating the symbol definition in our symbol table exactly. So what are the components you are managing over there? That is very important. See here, just observe. First one is what the symbol name we have. The first thing we need to maintain in our symbol table is symbol name. Then later, defining expression. Okay, like what is defined in the value field of a symbol, so that should be mentioned. Okay, then number of undefined symbol in the definition or defining expression. Okay, see sometimes example like buffer end minus buffer. Okay, so here if buffer is known, if buffer end is unknown, then how many symbols are unknown? Only one. If both are unknown, then the number of symbols unknown will be 2 exactly. So this type of unknown material, how many numbers you are having, that should be specified in your symbol. Okay, so 3 components are very essential. The undefined symbol marked with a flat star, okay, associate with a list of symbols dependent on this undefined symbol. Okay, means feel that we have one operand, okay, which is undefined. Okay, so it will be flagged as a star. Okay, and associated with, like we are providing a list where all other symbols are dependent on this particular undefined symbol. Example, like A is dependent on B and B is dependent on C exactly. Or else A is dependent or B and C are dependent on A exactly. And A is also unknown. Okay. Then while defining or while managing the value of A inside the symbol table, we need to provide 2 unknown references over here. Okay. What is that? B and C exactly. Next time we have an example, then you can understand it. When a symbol is defined, we can recursively evaluate the symbol expressions, okay, depending on the newly defined symbol. So when we go through the complete program, okay, so whenever we are identifying the new values of the undefined symbol, so based on this point number 4, okay, that references what we are having, like the relationship, whatever we are having, okay, according to that, recursively we can evaluate the dependent symbol values exactly. How we will do that? We'll take one example and we will do. Okay, so here multi-pass assembler example program we are having. Okay, just observe. So this is the sample program. Okay, okay. So this is what the sample program we have. Okay, here we are having a label which we are calling it half size. Okay, half size is equal to, this is also an operand or it will be a label or anything. Okay, half size will be equal to what? Max length divided by 2. Half of the size, okay, will be equal to what? Maximum length value what you have, it should be divided by 2. Okay, but feel that, so this is the first line of the program and this is the last line of the program. 1, 2, 3, 4, 5. 5 line of program we are having. Okay, so here, what is half size? You don't know. Okay, why? It is made equal to maximum length divided by 2. Now the question is, what is maximum length? See, if you consider this instruction, okay, if you consider this instruction, half size, I can get the information, but it is made equal to maximum length divided by 2. But here maximum length is unknown. Okay, what is maximum length? It is defined over here. Maximum length will be equal to buffer end minus buffer. Now, the question is, what is buffer and what is buffer? We don't know, so unknown it is. Here, half size is dependent on max length. Here, one thing is unknown. Max length is dependent on two things. Okay, here both are unknown exactly. Then, here we have one more operand which is named as previous byte, which is equal to buffer minus 1. So here we don't know what is buffer. We don't know what is buffer exactly. Okay. Then previous byte is also unknown exactly. So here such type of references, okay, which is creating a sequence of unknown operands. Okay. So here just observe. If I find the value of buffer, very careful, observe very careful. See, the value of buffer is mentioned in line number 4 and line number 5 exactly. You can easily identify. But very careful, very careful. Okay, here, if I get to know the value of buffer minus 1 will be very equal to previous one. Okay, so this can be solved. Okay, now if I know the buffer value, okay, so here one thing will be known. Second thing is unknown. Okay, then later, if I evaluate this particular instruction, buffering equals star, which indicates after this 4096 bytes, whatever we are having. Okay, so after that, whatever the unassigned location we have, that will be equal to buffer data. So after evaluating this, we will get to know like, okay, fine, what is the value of buffer? Okay, if I know this, then here two things are known. Okay, then maximum length easily I can compute. Right? If I can compute maximum length, then I can go for computing half size. What is half size? Maximum length divided by 2 exactly. Right? So this is how we are evaluating the program one by one. Okay. So this is possible if you are implementing the multi-pass assembler only. Okay, if you are implementing multi-pass assembler, then only we can identify, we can provide the complete information for the operands. Okay, fine. First we consider this first example. Half size is equal to maximum. 2 examples, right? So half size means what? I don't know. So this is an operand. So I will just place it for the symbol table. So this is the symbol table. Okay. There are 3 sections exactly. So this is the symbol name. Okay. So this is the symbol name, and this is the undefined. Okay. Hash of like number of undefined symbols in the defined expression. So this is the expression place. So here, how many values are undefined? That we need to mention over here. Okay, so half size was the operand. Okay, so maximum length divided by 2. Here, how many symbols are undefined? One symbol is undefined. Because of that ampersand of 1 we are writing. Yeah, then later, what is that expression? Okay, see here, the definition of expression. What is that expression? So that should be maintained over here. Because if I find the value of max length, I can just substitute over here. It should be divided by 2. Then the result can be computed here. Okay, so now this half size, whether it is defined somewhere else also, means whether it is like whether it is declared or whether it is mentioned in any other location. If not, we need to provide 0 over here. Otherwise, we need to provide a reference how we are providing over here. Okay, so now we'll go for the next value, that is what the maximum length, which is equal to buffer end minus buffer end. Okay, so here we are using max length. Okay, so that is also a symbol exactly. So for that symbol we are using over here. Okay, like inside the symbol table one more time. Okay, so maximum length. Okay, star. Fine, star we are using. Okay, means it is what undefined symbol. It indicates what undefined symbol. So this max length, okay, is specified where exactly? Half size exactly. Okay, so here in place of that we are providing a reference. Okay, indicates that max length is also defined in half size exactly. Because of that half size 0 here. So instead of 0, if I provide an arrow mark, apart from half size, if max length is defined somewhere else also, okay, that location also should be mentioned. Okay, so this is how we are providing the simple table entries for undefined symbols. Okay, we will do this max length. So here you can observe max length equals what? Buffer end minus buffer end. Next line. Okay, max length. Okay, means what? Buffer end minus buffer. So now we should search whether we have an entry for max length in case of simple table or not. Yes, we have entry over here. We have entry over here. But we are not dealing with this expression. We were having entry regarding this instruction exactly. Now, we'll start dealing with this particular instruction exactly. Now, just observe, buffer end minus buffer is an expression. Okay, how many things are unknown? Two things are unknown. Because of that, sorry. Okay, so just observe. So half size, how many values are unknown? Represent of one max length. Okay, so 0. Then max length. Okay, so here we have an expression buffer minus buffer. So here two things are unknown. That's the ampersand of 2 we are having. So this is the forward or the inlet reference. Okay, where max length should be updated after finding the value of max length. So where I should update the max length value in case of half size exactly. Okay, where it is here exactly. Now, what is buffer? Unknown. Okay, buffer is unknown. See, for the simplicity's sake, we are specifying max like buffer end over here and buffer over here. You can specify here itself, no issue. Okay, wherever you want, you can specify, no problem at all. So buffer star it is means we don't know what is buffer, where this buffer is defined, or where this buffer value we are expecting in case of the max length. That's why arrow mark max length. In case of buffer end also, okay, we don't know what is buffer end, so max length 0 we are going. Okay, means after finding the value of buffer end and buffer, where I should place in case of the maximum. Where you have maximum, here it is. Okay. Now, we go for the third instruction, that is previous byte. Okay, just observe here we have the statement previous byte equal to what? Buffer minus 1 exactly. Okay, so buffer minus 1 exactly. So here previous byte ampersand of 1, buffer minus 1, because we don't know what is the value of buffer. Now, just observe it very carefully. Okay, we are providing a reference, extended reference. Okay, where buffers are used in case of a max length it is used, and also in case of previous byte exactly. So here we need to provide the information that where all these values should be updated. Now, we feel that like first 3 lines of program we already read with. Okay, so here we are done with these 3 lines. So we are finding what is the value of buffer exactly? Buffer reserved by 4096, right? Okay, so what is the location of this buffer? We got to know, like, okay, we are feeling that in this example, we feel that buffer is at location 1034. 1034. So now we got the value of this buffer, the address of this buffer, that is 1034. Okay, so everywhere, wherever we are expecting it to be updated, okay, everywhere we are trying to update. Here, buffer should be updated in max length and previous byte exactly. So we'll see that. See, here, buffer is updated over here 1034. Okay, so here 0 we are placing because like we are not available with any kind of unknown result. Okay, buffer we have. Then, see, here, buffer value is equal to 1034. So previous byte was having expression called as buffer minus 1. So if we subtract 1 from this, what is the result in 1034? So that will be loaded for reserve byte exactly. But still we are with maximum length and half size. Okay, so now, sorry, just observe after reading that buffer value. Okay, when we are coming for the next line, which is buffer end equals to what? Star. Okay, so here the next to this buffer, okay, whatever the address we are having, that will be made as value of buffer end. Okay, so here buffer end and buffer is having total 1000 byte of difference. Okay, 1000 byte of difference. Okay, because of that, buffer end we are considering it as 2034. Okay, so buffer is 1034, difference is 1000. So 2034 will be the value of buffer end. Here 2034 we are having. So if you are subtracting these two values, then the maximum length will be equal to what? 1000, right? If you are finding the maximum length value, where it should be updated in case of the half size. What is half size? Maximum length divided by 2 exactly, right? Wait a second. Here we have written 800 exactly. Maximum length divided by 2. Maximum length if it becomes 1000, so 1000 divided by 2 will be 500 exactly. Okay, I think it is 500 itself, but it is looking like 800. It should be 500. Okay, so this is how we are updating. Like how many times we are passing the program is multiple number of times we need to pass that so that we should get a proper result in such time. Okay, if you are passing it for only 2 times, okay, then you are able to find the value of previous byte and you will be able to find the value of maximum length. But this absolute value remains unchanged exactly. Such things should not happen. Okay, so we are following multiple pass assembler over here. So this is the completion of module number 1. Okay, sorry, not module number 1, the chapter number 2 exactly. Okay, so we left with macroprocessor from the module number 1. So this big vast kind of syllabus, around like 150 page of your complete textbook. Okay, is covered by module number 1 exactly. So we'll go for the next topic, that is macroprocessor in next lecture. Thank you, students.